the last part of the boundary condition specification is to specify the contact surfaces. I need to specify the contact surfaces. That is where the parts can come into contact, and then the solver is going to use that information to determine the traction at the interfaces between the parts. And you can, so if you go under connections, contacts, and expand it, you will see that the contacts have already been set up. And I did that because I found that, you can, if you make one mistake in the contact, the model can, you can have a completely wrong result. So you have to be very careful in specifying the contact surfaces, and I've seen students kind of tripping up on it and running into all kinds of trouble. So this is a very important part. And I talked to Andy. So these were I got these from Andy, and he talks about, I have a video after this where we have a conversation about his thinking in coming up with these contact surfaces. But one thing you should do is specify these, specify the contact surfaces manually. Don't do it, don't use the automatic connection. So you would just, you'd have the automatic connections coming in, and you would just kind of delete them and then specify these one by one. Let's look at the bonded bolt to nut first, okay? And so that shows you, that highlights kind of the two parts that are in contact. And if you don't see these views, you can turn on body views. And so the contact surface is, if I move this here, is this part of the bolt, and the target body is the nut, is that surface on the nut. And this is a bonded contact, which means that these two, it's like these two parts are welded together over there. By the way, note that this surface of the bolt has been split into two, the region above the nut and where the nut is, and that's the right way to do it. Let's look at this one and contrast this to that contact. So this is the contact between the lower nozzle and the mid nozzle. And so if I play around with this and I zoom in here, okay, and I can rotate it, so I can say rotate and put like a pivot there. So that's the contact, that's the contact surface, okay. That's the driving, you can think of it as a driving surface. And let's look at the target surface, and I'll explain the terminology in a second. It's the corresponding faces on the lower nozzle, or rather the mid nozzle. Okay, what this means is, okay, so what the solver will do is, as the nodes, as it's estimating the deformation of these nodes, it'll check if it is coming into contact with either of these faces. And that check is actually quite expensive, which is why contact problems can take a long time to run. And I talked to Andy about which one to select as contact and target, so you can see that in the video with him. And then I recommend that you go in and review all these contacts. I quickly want to indicate how you would specify one of these contacts manually. So let's pick this one. Oh, by the way, this is set to frictionless, which means that these two surfaces can slide with respect to each other, but they cannot penetrate each other, which means that there is no tangential traction on these surfaces, but there's a normal traction that depends on how much they come into contact. And if so let me show you how to specify a contact like that. So highlight contact and right click and say insert manual contact region. And first we'll select the surfaces on the lower nozzle. So I'll select the face selection filter. Excuse me. And I'll click on any particular surface, and I will say hide all other bodies, and then select this face and that face and say apply. And then I will say show. So we know that, it's going to check that all the nodes on that face are going to contact. We'll check if it's coming into contact with the target faces. So I'll say show all bodies, and I'll highlight that and say hide all other bodies. Go in here, and for target, select that face and that face. And now I can show all bodies, and I change the type to frictionless. Okay, so it's not welded. They can slide with respect to each other, but they cannot penetrate each other. And of course, I was just demonstrating that, so let's just, once you've seen how to do that and practiced it, you can just delete it. And I'll say yes. That brings us to the end of the load specification. So the governing equations are specified and the boundary conditions are specified, and we can move on to solving the model.